PSpice advanced analysis, such as sensitivity and Monte Carlo analysis, are based on tolerances that you define for the parameters of the devices in your design. You can add tolerances to any parameter of any subcircuit model in your design, and the tolerance will be used in all instances in the design that use that subcircuit model. To assign tolerances to subcircuit parameters, select PSpice, Advanced Analysis, Assign Tolerance from this PSpice text menu. You notice that in our case, the Assign Tolerance option is unavailable. We are required to have a simulation profile defined before we can assign tolerances to the parameters of our subcircuit. So we'll first select PSpice, New Simulation Profile, and create a default simulation profile for a transient analysis. Now that we have a simulation profile defined, we can go back and select PSpice, Advanced Analysis, Assign Tolerance. Notice that we get a pop-up warning indicating that by assigning tolerances using the tolerance analysis window, our design will no longer be compatible with designs prior to the 11th ISR of the SPB 17.2 release. After selecting OK in the warning pop-up, a netlist will be generated for our design and the Assign Tolerance form will be displayed. To assign tolerances to subcircuit parameters, we use the Model View folder tab of the Assign Tolerance form, and all the subcircuit models in our design are listed in the left panel of the Assign Tolerance form. If we select a subcircuit model such as the QN3724 transistor, all of the parameters for the model are listed in the Assign Tolerance form, and any parameters that already have tolerances would be listed. And as we scroll down the list of parameters, we see that none of the parameters currently have any tolerances assigned to them. For our advanced analysis, we'd like to assign a 20% positive and negative tolerance to BF, the maximum forward beta K, the base to emitter depletion capacitor, and CJC, the base to collector depletion capacitor. To assign the tolerances to these parameters, we select the Edit PSpice Model button in the Assign Tolerance form to open the PSpice Model Editor. And in the PSpice Model Editor, we can see our BF parameter, our K parameter, and our CJC param. To add our tolerance to BF, the maximum forward beta, will simply use the syntax dev/uniform and then include our tolerance of 20% for the positive tolerance and 20% for the negative tolerance. The word uniform indicates a flat tolerance distribution for our tolerance. Our other option would be a Gaussian distribution, which is what we'll use for KR base to emitter depletion capacitor. For K, we'll use a similar syntax to define a Gaussian distribution, and again, a 20% positive tolerance and a 20% negative tolerance for our K parameter, and finally, for CJC, our base to collector depletion capacitor will also include a 20% positive and negative tolerance with a Gaussian distribution. We'll save our model in the PSpice Model Editor and then close the PSpice Model Editor. After closing the PSpice Model Editor, the Assign Tolerance form indicates our positive and negative tolerance on BF, our maximum forward beta with our flat distribution, and as we scroll down, we can also see the 20% positive and negative tolerance on CJC and K with our Gaussian distribution, and we pick OK in the Assign Tolerance form to complete the process. When a PSpice advanced analysis is run, parameters with tolerances will be assigned a random value with a minimum of the nominal value. minus the negative tolerance and a maximum value of the nominal value, plus the positive tolerance. The tolerance distribution determines the probability of a value in the specified range being selected. You could choose either a flat distribution or a Gaussian distribution for the tolerances in your design. A flat distribution provides a constant probability from the minimum to the maximum range for a parameter. The Gauss distribution, also known as a normal distribution, selects random values based on a symmetrical, bell-shaped distribution where values closer to the nominal value of the device have a higher probability of occurring. Our modified subcircuit models are stored along with our design. If we open a file explorer and navigate to the same directory where our project is, we find a PSpice files subdirectory named after our project, and if we descend into that directory, we see a libs file, and if we were to edit this lib file in an ASCII text editor, we can see that our tolerances have been added to this PSpice library. Also, if we go to our simulation profile and edit it and were to go to the configuration files category and look at our libraries, we could see that our modified library has also been added to our simulation configuration. We can reuse the tolerances on these models by simply referring to this PSpice model library in any of our future designs.